Imagine searching for something that may not even exist, night after night, scanning the vast sky, hoping to find a tiny speck moving among the stars. That was the mission of a young astronomer named Clyde Tombaugh. And in 1930, he found something incredible as a result of these efforts: Pluto, a new planet. Or so everyone thought. But to understand why Tombaugh was searching that part of the sky in the first place, we have to go back a few decades, to a man named Percival Lowell. Lowell was convinced that something lurked beyond Neptune. He believed its gravity was tugging on the orbits of Uranus and Neptune, disturbing their paths. This planet X, as he called it, had to be out there. He even thought he knew approximately where it would have to be hiding. Lowell spent years searching, but he never found it. When he died in 1916, his observatory carried on his work. And in 1930, a determined 24-year-old Clyde Tombaugh was still on the hunt. For months, he painstakingly compared images of the night sky, looking for the telltale movement of a distant world. And then he found it, right where Lowell had said it would be, a tiny dot shifting ever so slightly between photos. He'd found something new, something real. The world erupted in excitement. The solar system now had 9 planets instead of 8. But you probably already know that Pluto's days as a planet were numbered. Today, we'll take a look at Pluto's eventual fate and how its planetary status became a victim of our growing understanding of the solar system. Clyde Tombaugh's discovery of Pluto in 1930 was a triumph of patience and precision. The world embraced Pluto as the long-lost planet X that Percival Lowell had predicted. But there was just one problem. Pluto was small, much smaller than anyone expected. In fact, it was only about half the width of the United States. Why would this have posed a problem for Pluto's status as the long-searched-for planet X? Pause the video for a moment and make a prediction. Remember that Lowell was searching for planet X because he thought something was tugging on the orbits of Uranus and Neptune. But Pluto was tiny and couldn't possibly have enough gravity to affect the ice giants. If this was planet X, it wasn't very impressive. In fact, it's so small that its discovery at the time would have been nearly impossible if Tombaugh hadn't been studying that section of the sky so carefully based on Lowell's predictions. Then, decades later, something surprising happened. Astronomers took another look at the calculations that led Lowell to look for planet X in the first place, and they realized there was no mystery object at all. The supposed wobbles in Neptune's and Uranus's orbits, they weren't caused by an unknown planet. Astronomers had simply miscalculated their paths. Oops. Pluto was never pulling on them because it was never big enough to matter. So its discovery was truly an accident. It just happened to be in the right place at the right time. But that was okay. Pluto was already part of the family. No one questioned its status as the 9th planet. That is, until we started discovering Pluto's neighbors. As telescopes improved, astronomers began to notice something strange. Pluto wasn't alone. In the 1990s and early 2000s, scientists discovered a whole collection of icy worlds that shared this space with Pluto, a region now known as the Kuiper Belt. And some of these Kuiper Belt objects were a lot like Pluto. There were other oddities with Pluto as well. Unlike the 8 major planets, which have relatively circular orbits, Pluto's path around the Sun is stretched and tilted. In fact, for about 20 years of its orbit, Pluto is actually closer to the Sun than Neptune is. And then came the final blow. In 2005, scientists discovered Eris, an object even farther from the Sun than Pluto, and it was nearly the same size. This raised a big question. If Pluto was a planet, shouldn't Eris and these other Kuiper Belt objects be called planets too? Or should none of them be called planets? Suddenly, astronomers had a choice. Either our solar system contained over a dozen planets, or it only had 8. But 9 didn't make any sense at all. Because while Pluto may have been the first Kuiper Belt object we discovered, it wasn't different from its Kuiper Belt neighbors in any other significant way. The stage was set for one of the biggest debates in modern astronomy. What really makes an object a planet? And does Pluto truly qualify? Perhaps it was time for astronomers to make an official definition to settle the debate. In 2006, after 2 years of careful deliberations and discussion, the International Astronomical Union came up with an official definition of a planet. To be considered a planet, an object must meet 3 criteria. 1, it must orbit the sun. 2, it must have enough mass to be nearly round. And 3, it must have cleared its orbit of other debris. And this is where Pluto failed the test. But what does it mean for an object to clear its orbital path of debris? Over time, a planet's gravity should dominate its region, with small objects being pulled in and absorbed by the planet. This ensures that the planet is the primary influence in its orbit, rather than sharing space with many other bodies. Unlike the 8 major planets, Pluto shares its orbit with many other icy bodies in the Kuiper Belt. It doesn't have enough gravity to clear its neighborhood the way Earth or Jupiter do. So according to the new definition, Pluto was out, and none of its Kuiper Belt neighbors made the cut either. Instead, Pluto was placed in a new category, dwarf planets. It joined other Kuiper Belt objects, Eris, Haumea, Makemake, as well as the asteroid belt object, Ceres. So our solar system is currently described as having 8 planets and 5 dwarf planets. But who knows? More dwarf planets could be discovered any day. This decision to demote Pluto from its place as a true planet wasn't exactly popular, though. It turns out that Pluto had fans. Many people had grown up with Pluto as the 9th planet, and they weren't happy about the change. But science isn't about what's popular. It's about making sure our definitions match what we actually observe. If it had been up to you, how would you have defined a planet? Would you have changed anything on the IAU's list? Pause the video for a moment and record your own criteria. Would Pluto have made the cut on your list? Could the IAU have chosen to define a planet differently, such that Pluto and the other dwarf planets were included? Sure. Science is full of hard decisions about how to classify objects and define concepts. But when the leading experts in the field, the people who know more about these topics than literally anyone else in the world, come to an agreement about what makes the most sense, it's probably best to trust their judgment, even when it means giving up our favorite planet. And Pluto's story didn't end there. In 2015, 9 years after losing its status as a planet, NASA's New Horizons spacecraft flew past Pluto, revealing an incredible world with towering ice mountains, smooth plains, and even signs of possible underground oceans. Dwarf planet or not, we still have much we can learn from this much-loved former planet. So, do you think our solar system ends with Pluto and the other Kuiper Belt objects? Actually, no. In terms of distance from the Sun, this is still only the beginning. Far beyond Pluto, stretching almost halfway to the next star, lies one of the most mysterious regions of space, the Oort cloud. The Oort cloud is a vast, distant reservoir of icy bodies, possibly containing trillions of comets. Unlike the Kuiper Belt, which is a flat disk, the Oort cloud surrounds our solar system in a giant spherical shell. Sometimes a passing star or the gravity of the galaxy itself disturbs one of these icy objects in the Oort cloud, sending it hurtling toward the sun. These become the long-period comets we see from Earth, like the famous Halley's Comet, which returns every 76 years. While we haven't directly observed the Oort cloud, it's just too far away, its existence helps explain why we see comets appearing from all directions in the sky. So while Pluto was once thought to be the farthest planet, it turns out our solar system extends much, much farther. And out there, on the edge of interstellar space, are the frozen leftovers of our solar system's birth, waiting, just maybe, to tell us even more about where we come from. As we learn more about our solar system in the coming generations, maybe we'll need to rethink our classification system once again. But that's how science works. The more we know, the better we can explain. Well, that's it for today, Space Explorers. Be sure to check out the lesson activities to learn more about these mysterious objects at the edges of our solar system. And always, keep marveling at the wonders of our universe. See you next time!